Hello friends, let's begin with case study based on modeling and analysis of dynamic, that is vibration analysis system. In this model we are going to discuss some of the examples which are related to dynamic system or vibration analysis. So let's begin. Dynamic analysis mainly divided into two parts, that is free analysis or free vibration analysis or forced vibration analysis. When it is come to the natural frequency, that is related to modal analysis or free analysis. So the frequency at which any object will vibrate, if distributed and allowed to vibrate on its own without any external force. That means without any external force, by any external force applied on that particular body, it will automatically vibrate. That is called as natural frequency of the object, and that is defined Wn is equal to root of k by m. So m is the mass, and k is the stiffness. Okay, and Wn is the frequency in radian per second. While response to external excitation is having three types of analysis, where first one is frequency response analysis, second one is transient response analysis, and third one is random vibration. So in frequency response, that is frequency domain, it is related to steady state or sinusoidal excitation. So the waves are in sinusoidal form, and it is limited to linear elastic structures only, and rotating machineries, unbalanced tires, helicopter blades, those are considered in a frequency response domain. While transient response, that is time dependent, time domain, with respect to time, the frequency will change. That arbitrary but well defined excitation and constant acceleration or force at a given frequency, and road excitations, etc. Okay. For example, road excitation. So frequency is continuously changing with respect to time as per the vehicles are passing on the road. Okay, so that is one of the examples. Then random vibration. Random vibration is a random nature of loading and usually input in the form of PSD, that is power spectral density. Okay, so remember this. These are the random vibration. Now this we will learn in a further side once again with examples. Okay, so equation of motion for this solid body and conservative forces, we get the equation of motion for a particular vibration problem. Those are mass into acceleration plus damping into velocity, that is dx by dt, and k into x, that is stiffness into displacement, is equal to external force and with respect to time. Okay, so first m d2x by dx t square, that is the inertia force, while c dx by dt, that is the damping force. So this is the inertia force due to body. This is a damping force, and this is our K, that is internal resistance force, is equal to external force. Where ms double dot, that is m d2x by dt square, is equal to 0, and c dot is equal to 0. That time K and Ft will be constant, that is linear static condition, where ms dot double is equal to 0 or cs dot is equal to 0, K is equal to Fx and Ft. If it is considered as Fx, so Kx is equal to F, that is the time is not considered, then linear static. If time is considered, then it will be non-linear static. Okay, when the Ft will be 0 and Cx dot will be 0, so Mx double dot plus Kx is equal to 0, that is the free vibration condition, that is free analysis without any having external load, that is force applied on the body. And all the terms are present in one equation are available, then it is considered as a forced vibration. So dynamic vibration analysis having different types. One is modal analysis, then transient dynamic, random vibration, response spectrum, a seismic analysis and multi-body dynamics analysis. Most of the cases, multi-body dynamics analysis is considered as a separate domain, but I am considering in the dynamic vibration analysis. So if you observe that this is a modal analysis of any particular structure, base of the structure. So where we get a little bit twisting movement of the object at different frequency. That frequency is 191 hertz. So when any structure or any vibration which causes a resonant frequency, that time that structure will be felt. Okay, as like our any dam, okay, hanging way bridge are there. Those are way bridge. They are going to collapse. When they are going to collapse, when the frequency on vehicles or frequency of human being and some another external frequencies, okay, or sometimes the frequency that is inner frequency. Okay, so that inner frequency, that is no external agencies applied any force on that. That time it automatically uh, increases, and at a particular location, that frequency causes a resonance. Okay, so resonance phenomena is considered in a modal analysis. According to natural frequency, it will be break, start break. Okay, so modal analysis is very important part of any type of vibration problem. Okay, then transient dynamic analysis, like time versus acceleration, we plot a loading unloading graph. Okay, when load is applied, how the time and acceleration will vary within a particular time frame. So that is considered as a transient dynamic analysis. Okay. So continuously forces are applied on that particular object. At that time there is a transient dynamic analysis. Where random vibration analysis, for example 0 to 100 hertz, the randomly forces are applied on some of the different objects. For example, in an industry there are many machineries are there, and one particular machine is newly set up there. But due to other machine vibration, it will affect on that particular system. Okay, and that component can be failed due to other conditions. So that time, those vibrations we for that purpose we mount the anti-vibration mountings. Okay, so those are not studied here in detail, but I am showing that random vibration purpose, the frequencies are not in sequence form or not in sinusoidal wave. Those are frequencies we are getting in any type of frequency. Sometimes we get a larger, sometimes we get a lower. So random input is given, so that random input is converted into PSD structure, that is power structural density. Okay, so this is the input with respect to frequency will be given to the random vibration analysis. Okay, and after giving that input, we get the frequency or some of the other parameters of the deformation of a particular component due to random vibration. Okay. Then we move to the seismic analysis or a response spectrum analysis. That means if we this is a LNG tank, and if you observe that there are the base structure is fixed and there is a green line here, so those are having frequency acceleration versus frequency graph. That means seismic analysis comes when we are or earthquake is coming, and due to earthquake that structure is going to collapse. Okay, so due to earthquake, many of the structures and many of the tanks will be collapsed, and that causes another failures, and that will cause a human loss also. So that purpose we have to check the response spectrum analysis, and accordingly the acceleration versus frequency graph will be mounted. Okay, so this is related to seismic analysis. While multi-body dynamics is having prismatic joint, that is sliding mass is there, then flexible beam is there, revolute joint and rigid driving body, and driving torque is given to here. So in multi-body system is here it is like a piston cylinder or single crank mechanism is there. So, where the two or more bodies are connecting together and they are in continuous motion, that time this multi-body dynamics is plays important role. While every body is carrying some of the weight, itself weight and another forces which are applied on the every section. So multi-body dynamics is a rigid dynamics, while actually in the motion how the effect on a particular system will be taken place. Okay, so those are considered here. Then raw water pumps, which are experience high vibration and failures in a vertical turbine pump. If you observe that there are the vertical turbine pumps which are shown here, that is one of the cross section, and the fixed piping is a support is given to the here, and this is a fixed case. Okay. Due to the motor condition or due to the pump condition, whatever the effect we are getting, those are plotted or those are frequency we are getting, those are mentioned here. An original discharge head is like this, but modified discharges we have to provide the sum of the risk. Okay, because it's not going to fail the particular structure. So while designing the pump head, okay, that time also the frequencies will affect on the system. Okay, so water frequency also affect on the system. If it is having a high vibration, high velocity of water pump or feed pressure is there, so in that time what will happen? That time the original discharge rate will be collapsed or it will be having very high impact and it will start cracking. It should not be cracked. So for that purpose, we need to modify the head according to the high vibration failure to reduce the vibration on the mounting. So that is shown in this figure. Thank you so much. Hope you understand very well.